this integral belongs to case 1 of integration by partial fraction. Case 1 is we have distinct linear factors in the denominator, but this is a special problem because the leading degree of the numerator is greater than the leading degree of the denominator. So what is leading degree? The leading degree is the highest degree. So the highest degree on top is 3. The highest degree on the bottom is 2. So top is greater than bottom. We will have to use long division to reduce the degree a little bit. So long division. So what is long division? So let me review this for you. So let's say I ask you to perform 7 divided by 2. How do you perform this? So you have to do this. So 7 divided by 2, right? So you put a 3. 2 times 3 is equals to 6. 7 minus 6 is equals to 1. So 7 divided by 2 is equals to the quotient plus the remainder divided by the denominator. So let me put this in general. So we have dividend divided by divisor that is equals to quotient plus the remainder divided by divisor. But how do you put this on polynomial? So for polynomial, so let's do this just do this in yellow. So the divisor is x squared minus 3x plus 2. And then the dividend is the top, right? So we have x to the third. Do you see that the second degree is missing? So when the second degree is missing, we have to, make the second degree right there. So how do we do that? All you have to do is you do a 0x squared. 0x squared is just equals to 0. And then minus 4x and then plus 1. Check the dividend. You have the third degree, second degree, first degree, and the constant value. So since there are 3 terms in the denominator, we have to use the first 3 terms. I have to think about a number, or I have to think about a term such that that term multiplied by x gives you x to the third. So what number goes up there? The answer is x, and this is the only option. X times x squared is x to the third, so that is the only option. And then x times negative 3x, so that is negative 3x squared. X times 2, that is 2x. And then you subtract the whole thing. Please use parentheses. You subtract the whole thing. Why? You will see that in a minute. X to the third minus x to the third is equals to 0. If that is not equal to 0, that means the term you just put up there is wrong. And then 0 minus minus. So that will be 0 plus 3. So you get a 3x squared. And then negative 4 minus plus. So negative 4 subtract 2. You have negative 6x. And then you pull the last term down. And then the next term must be 3. 3 times x squared is equals to 3x squared. That is the only way to eliminate the first term. And then 3 times negative 3, negative 9. 3 times 2 is equals to 6. And then you subtract them one more time. Please use a minus and a parenthesis. 3 minus 3 is gone. This parenthesis reminds me I am doing a subtraction. Negative 6 minus 9. Negative 6 plus 9 is equals to 3. 1 minus 6 is equals to negative 5. And then you are all done. So let's update the result. We have x to the third minus 4x plus 1 divided by x squared minus 3x plus 2. That is equals to the quotient plus the remainder over the divisor, which is x squared minus 3x plus 2. And then the next step is we have to factor the x squared minus 3x plus 2. Okay, so now let's change this to another color. You are trying to integrate this, right? So that means you are trying to integrate this and integrate that. So let's do the partial fraction right now. So you have a 3x minus 5 divided by x squared minus 3x plus 2. So this one you factor that. That is 3x minus 5 divided by x minus 1, x minus 2. You don't have trouble in factoring, right? So they are distinct, right? They are not the same, and they are linear. So x minus 1 is linear, x minus 2 is linear because x is raised to the first power. So a divided by x minus 1 plus b divided by x minus 2. the order of A and B is not important. And then for the common denominator, you have 3x minus 5. 3x minus 5 divided by x minus 1, x minus 2, and then the a divided by x minus 1. This I am looking for a x minus 2. I will put that up in a minute. This one I am looking for at x minus 1. So let's complete that right now. I am looking for x minus 2, x minus 2. This I am looking for x minus 1, x minus 1. I just multiplied them by 1, so I did not change the problem. The next step is you have to perform a distribution on top. 3x minus 5, that is equals to a times x minus a times 2 plus b times x, b times negative 1. And then you group the x and the constant together. 3x minus 5 is equals to ax plus bx, and then minus 2x minus b, right? Minus, no, whoa. I was doing this too fast. A times x and then a times 2. You might already catch my mistake. So 2a, ax 2a, bx minus b. All right, so ax plus bx, that's 1. And then plus, how about this? Let's put all this in one parenthesis. All right, so after you add them, they are still minus 2a and then minus b. Okay, let's do the equating coefficient. And then 3 is, should we do another line? Yes, we should. 3x minus 5, factor out the x, a plus b, and then plus minus 2a minus b. Okay, let's do the equating coefficient. And then 3 is equal to this, because 3 is the coefficient of x, a plus b is the coefficient of x, and then 5 is equal to, negative 5 is equals to the whole thing. All right, and then we equate the coefficient. So equate the coefficient. I will just write COEFF for short. So we have a system. 3 is equals to a plus b, and then negative 5 is equals to negative 2a minus b. And then you have to solve this system. Whew. Okay, let's add them. Negative 3 plus negative 5, that is equals to negative 2. Negative 1 plus negative 2, that is equals to negative 1. 1b plus a negative minus b is gone, so you have a equals to 2. And then when a is equals to 2, 3 is equals to 2 plus b, and then clearly b is equals to 1. So now we got it. A is equals to 2, b is equals to 1, and then you have to look back. Don't go too fast. When you look back, do you still see that there is an integral x plus 3, right? Don't miss that. You did all the hard work. You don't want to miss the final step to lose points. Okay, so there is x plus 3. Let's bring it down. So overall, you have integral x plus 3 dx plus, this is for the a, 2 divided by x minus 1 dx. And then for the b, you have 1 divided by x minus 2 dx. So this is 1/2 x squared, right? Plus 3x. And then this is a 2. Still remember this, ln absolute value x minus 1. And then ln absolute value of x minus 2 plus c. There you go. That is the final answer. All right, so if you think my explanation is clear, give me a like, let me know in the comment below, share the video for me, subscribe to my channel. Appreciate for your help and support. See you all in the next one. Signing off for now.